Okay, guys, I hope you are able to remember what we went through on Monday in terms of infinite series. Just perhaps a quick recap. Remember, we can only work with geometric series when we're wanting to find the sum of infinite number of terms. And in particular, we've got to work with only convergent geometric series. Okay, so convergent geometric series, just to remind you of that as well, that occurs when the R value, so our common ratio, lies between -1 and 1. So we're looking at a fraction, and the idea there is that as the series grows, as we increase the number of terms, the values of the terms become so infinitely small that when we add them, they're actually insignificant. Okay. Right. Now, what I've done, or what I want to do today, is go through a couple of examples, okay? And then you guys are going to do 2 examples or 2 questions from the textbook. So on the classroom, I've posted a little bit of a worksheet with 3 questions on it. Hopefully you've been able to open that and you're able to look at it. At the moment, I've got it open and I've got my board here, and we're going to work through some of these answers. Well, we're going to work through all these answers together. Okay, so starting question 1. I've kind of abbreviated the question on my board. So we've been given that Tn is equal to 4 multiplied by a half to the n plus 3. And we've been asked to calculate the sum to infinity. So we first of all need to remember that our sum to infinity has the formula a over 1 minus r. And in order to be able to do that, we need to know both the a value and the r value. So we don't have consecutive terms to be able to work out those. We don't even have the first term. All we have is this general term, the general formula over here. So what we do is we actually generate 2 terms. We know that it has to be geometric because that's the only way we can find the sum to infinity. So I'm only going to calculate 2 terms. The first term is 4 times a half to the 1 plus 3, and a half to the 4 is 1 over 16. So this is going to be multiplied, 4 multiplied by 1 over 16. So we have T1 as a quarter. Right. Then I move on and I calculate T2, which is done in exactly the same way, except now in the place of n, I'm going to put a 2. And half to the 5 is 1 over 32. So term 2 gives me 1/8. Remember that T1 is my first term, which is the value of A. In order to work out R, remember it's the quotient of 2 consecutive terms. So this here is 1/8 divided by 1/4, which if you just do that on your calculator, you get an answer of a half. So going back to this formula up here, we now have our A value, we have our R value. We can actually now calculate our sum to infinity. Sum to infinity is A over 1 minus R. So it's a quarter over 1 minus a half. which is a quarter, divided by a half, which gives me a half. So the sum to infinity, the sum of all the terms generated by this formula, given formula up here, is a half. Are there any questions there, guys? Okay, we're then going to move on to question 2, which is a little bit more involved. I'm sure there might be other ways of doing it. I just think that they would probably become a lot more involved and a lot more working involved. How were you thinking about doing it? Oh dear, shame. Are you able to type it? Matthew, glad that you could join us. Are you talking about this TN one? You're wanting to manipulate the TN formula. And how would you go about that? Okay, maybe Fadzani, you can write it down on a piece of paper, send it to me as a WhatsApp or send it to me on email, and then we can have a conversation about that. Okay, I'm going to move on to question 2. And question 2 gives us the series. X plus 3 plus x minus 3 plus 12 minus x. And it tells us that that is a convergent geometric series. So those two words are very important, as they're able to tell us that, first of all, we have a common ratio, okay? And secondly, what it tells us is that our ratio lies between -1 and +1. And that's what we need to work on to be able to answer these questions. So the first question is saying to us, show that x does not equal -3/2. Now there's two ways that we can go about this, okay? The first way is a plane forward substitution. So what do I mean by that? if we do have a convergent geometric series, it means that x minus 3 over x plus 3 must equal 12 minus x over x minus 3. Okay. If that is not true, then the value for x does not hold. So I'm going to substitute into the left-hand side this value for x. So we're going to have negative 3 over 2 minus 3 over negative 3 over 2 plus 3. So the answer I get here, which works out to, that's negative 4.5 over 1.5. Okay, which if we work that out, negative 4.5 divided by 1.5, we get an answer of negative 3. Wow, that was poor. Thank you, Sohail. It took me far too long to do that one. Okay. If we then do this on the right-hand side, what do we get? Twelve minus negative 3 over 2 over negative 3 over 2 minus 3. So that gives me 13.5 divided by negative 4.5. Thank you, Sohail. You saved me the calculation there. We get negative 7 over 3, which is clearly not 3. Sohail, I'm sorry, I'm going to have to disagree with you here. My calculator tells me I get negative 3. No problem. At least you're interacting. I'm getting some feedback. I feel like I'm in a classroom. I don't know if you guys are just tired today or if it's just me. Okay, so this method over here actually doesn't prove anything to us because our common ratio is the same. So that actually doesn't help us to show that x cannot equal negative 3 over 2. Let's have a look at an alternative method. The alternative method is using this to be true. And solving for x. Okay, so if we take this, that means we get...
Sorry, so can you move your board over? We can't see what you're writing.
Oh, sorry. Is that better?
Yes, sir.
And that is equal to 12 minus x times x plus 3. Solving this equation, x squared minus 6x plus 9 is equal to negative x squared. Doing that first. Then doing That's negative 3x plus 12x. I get plus 9x. Okay. Plus 36. Just moving it all over to the one side. I think I end up with that equation. Which gives me okay, guys. It must be my brain today. I'll come back to this over now. See how my brain's caught up with reality. If we factorize this, we end up with those two values, which tells me that perhaps x can be negative 3 over 2, or x is 9. So both of these methods appear to actually be showing us that x can be negative 3 over 2. We get an answer here after solving the equation, which gives me that negative 3 over 2, and my two r values over here also seem to be work. They are consistent. The one thing that slipped my mind, which should never have done so, is the fact that up here, what we've actually worked out in both these values is in fact r. Okay, we've taken term 2, divided it by term 1, simplified it, taken term 3, divided it by term 2, and simplified the answer. Right. But the problem exists here, and this is why it was important. Yes, it is geometric. Okay, so the r values are the same. But the thing that I've forgotten is that it's a convergent geometric series, which means for convergent, remember, my r value must lie between negative 1 and 1. This r value here is greater than negative 1. I mean, smaller than negative 1. So therefore, x cannot equal negative 3 over 2, because when x is negative 3 over 2, I get a divergent geometric series, not a convergent one. Okay. Sorry for that little blups, guys, but hopefully you understand what we've done here and how we've got to that point. Okay, so maybe let me just go through it very quickly again to hopefully give you an overview of what we've done. We know it's a geometric series. The question tells us it's geometric. So if it's geometric, it means that term 2 over term 1 must give me the same answer as term 3 over term 2. Once we've done that, set that up, okay, we can just use one of these with the substitution of the value to work out what r is. We should expect the same answer because they are geometric. But the big thing comes in here is that that negative 3 doesn't obey the convergent rules. Okay, so Rachel, you're absolutely 100% correct. This blue part that we did over here, or that I did over there, was actually completely unnecessary. If I'd actually woken up to this fact when I should have, I wouldn't have taken you through all of that problem. Okay, so at the end of the day, because R doesn't lie between -1 and 1, my X value is not allowed to equal 3/2, -3/2. Okay, we happy with that? The B part that I've just rubbed out, or the part that I've just rubbed out now in blue, was actually the answer for part B. So part B then asks us to work out the value of X. Then we've already done that whole equation. I've just rubbed it out. We got the two answers there of X equals -3/2, which we now know is not acceptable. The other answer we got there was X equals 9. And that's the answer that we're allowed to have. What is the problem with it equaling 9?
But is 9 not in between 1 and -1?
X doesn't represent R.
Oh, right. Okay, thank you.
Thank you. That's exactly what I was going to say, but that's great. X is just a number to be able to generate these terms. We haven't calculated X here, we've calculated R in this question. Over here, if we put X as 9, we get term 1 to be 12, we get term 2 to be 6. So my R value there is actually 6/9, which is 2/3. And 2/3 definitely falls within the values for R. Yes, Rach.
So how did we get that blue equation in the first place again? Like, where did we get it from?
Okay, so the blue equation came from creating term 2 over term 1 and making it equal to term 3 over term 2. And from there, so we've got the X minus 3 over X plus 3 is equal to 12 minus X over X minus 3. I then multiply this X minus 3 to the top there, and this X plus 3 to the top on that side, and got X minus 3 squared, 12 minus X plus 3. And then that's the equation that I solved to get those two answers. Okay, guys, any other questions about that? I think, Fazani, going back to your questions, so can we ever skip a question if it's asked something we've already proved? So I think what you're saying there is if you solved for X in question A, can you just leave question B out? I think that's what you're asking. So the answer there is rather don't. Even if you've done the working in A, then in B, just do what I've done over here. Maybe add in a statement that says from A, X equals that or X equals that. So at least the examiner knows that you've answered question B and not just skipped it out. Right. I want to get on to at least starting question 3. I know we're running out of time in the lesson. But at least if I can start it, then hopefully you'll be able to complete it and then do the 2 questions from the exercise as well. Remember, I am available on WhatsApp and email, and I will be on Maths X this afternoon as well, from 2 until 3. Right. So in question 3 now, we actually come to a word problem. And as I said to you, or thought I said to you, the biggest part or the biggest place where these sum to infinity questions are going to be asked is going to be in word problems. All right, so let's look and see how we can go here. So the question says, as hollow plastic hemispheres are created such that each successive one fits into the previous one. Now, a more complex type of situation, or perhaps a real life that you might have actually come across, is those Russian dolls, where you keep opening the doll and there's another doll inside, you keep opening and it just keeps going and going and going. A very simplified type of question that's been given to you here, because you're just dealing with a little bit of a bowl, okay? And it gives you the radii of the first 3 hemispheres shown below. You also get given the formula for the surface area of a hemisphere. The question asks, determine the sum of all the outer surface areas. Okay, so that's the shaded parts in the diagram, of all such hemispheres created by continuing the pattern indefinitely. So what we need to do is establish our series. So in our first term, my radius is 21. Okay, so my radius is 21, which means my surface area of the first one, so surface area 1, is 2 times pi times 21 squared. Now, I'm quite happy for you to leave your answers in pi here, in terms of pi. So this term 1 should be 882 pi. Term 2 is my surface area 2, and now we're using the radius of 3. So it becomes 2 times pi times 3 squared, which is 18 pi. Right, and my term 3 is surface area 3, which is 2 times pi times 3 over 7 squared. Okay, which gives me 18 pi over 49. This is quite a horrible number to work with, so I'm not going to really worry about it at the moment. I am going to do a calculation to confirm that we're dealing with a convergent geometric series. Because if we're not dealing with a convergent geometric series, we cannot find the sum to infinity. Okay, so let's just take term 2 over term 1. If I do that calculation, I get 18 pi over 882 pi. The nice thing here is that pi will cancel out, and we can simplify the 18 over 882 down to 1 over 49. Okay, so first of all, our requirement here for r lying between -1 and 1 is met in this calculation. So at least we know that if the series is geometric, then it is convergent. So let's now go ahead and prove that it is geometric, and we work out the calculation T3 over T2. So here we've got to bring this horrible thing into play. 18 pi over 49, and I'm dividing that let's write it a different way. Dividing that by 18 pi, which becomes multiplied by 1 over 18. Now this actually works out quite neatly for us as well, since the pi's do cancel out again, and the 18s also cancel out. And that leaves me with an answer of 1 over 49. Okay, so both these answers are equal. That proves that I'm dealing with a geometric series. They are both between, well, -1 and 1, which means I do have a convergent geometric series. So I can go ahead and calculate the sum to infinity. Term 1 is my A value. That's my 882 pi. And my R value is my 1 over 49. So it's minus 1 over 49. And we can then calculate that. And we can get 2,828,61 if we round that off to 2 decimal places. If we don't round it off to 2 decimal places, then we get quite a nasty looking number, 7203 over 8 pi. Right, guys, hopefully going through some of these examples has made it a little bit clearer than mud for you. And we'll be able to do that exercise on the textbook. I've put for those of you who've said you don't have the textbook with you, I have put photographs of those pages up on Classroom. If I'm not mistaken, there's only 2 questions there that I want you to do. As I said, if you're not 100% clear with this, and if it's not sitting nicely in your brain, then I am on Maths X this afternoon from 2 until 3. Please feel free to come online. I'll post the link on Google on the Classroom just before the end of the day. Okay, guys, unless there's any other questions, I'm done. Thanks, guys.
Sorry, sir.
Yes, who was that? Sorry.
Van, sir.
Yes, Van, sorry.
Sir, I was actually looking at the arithmetic sequence, not sequence, the series, sir, and I saw like the other formula with A equals L, sir. So L would be the last term, sir. So in the sequence, like let's say you get a sequence, not a sequence, what a series of numbers, like 2, 4, 6, 8. So would the last number be 8? Would the L be 8?
Yes, that's correct. But remember that formula only works with arithmetic.
Yes, sir.
Yeah,
Okay.
but absolutely. So L would be your absolute last term
Okay.
of the values that you're adding.
So if there's only 2 numbers, then A would be the first one and L would be just the last one, the second one.
Yes, correct.
Okay, sir. Cool. Thank you very much, sir.
Okay. Roman, I'm trying to remember which ones I've said. It's the 2 word problem, but questions 8 and 9 from exercise 1.9. So it's the 2 word problem questions there. So Hale,
Sir.
I will post those answers.
Thank you, sir.
Okay, is that what you were going to ask?
Yes, sir.
Okay, I will post those answers from the 26th.
Sir, do you know about what time you're gonna post the recording of the lesson?
Patsimo, I'll probably only post it. I'm now going into another lesson and then into another lesson, so I'll probably only post it at about 11 o'clock.
Okay, thanks, sir.
Okay. Cheers, guys.